Let's talk about a challenge you may have come up against. You're running Nutanix Flow Virtual Networking. Your VPCs are working well, and your environment is growing. More VPCs, more workloads, exponentially more traffic. But as you scale, you might begin to notice something. Your VPC gateways are starting to feel the pressure of all these workloads. You hit an inflection point where the original gateway architecture can't scale with you as you grow. You're concerned that one of these gateways could fail, and that failure could result in an interruption you can't afford. The good news? There are better ways to scale your Flow Virtual Networking VPCs. Hi, I'm Eric Walters, a technical marketing engineer at Nutanix. In this video, we're exploring how Nutanix Flow Virtual Networking has fundamentally transformed VPC external network scaling, and we'll walk through how to do that the right way. Then we'll dig into Transit VPCs, a game-changing architecture that actually simplifies your infrastructure as you grow, no matter how complex your multi-VPC environment becomes. Let's dive in.
Let's start by reviewing how you connect your Nutanix Flow VPCs to the outside world. This is all done through external networks. Think of external networks as the bridge between your virtual workloads and physical infrastructure. They come in two flavors: NAT, which keeps your internal IPs hidden, and routed or no NAT, which allows you to expose your overlay addresses directly to the rest of the network. Before AOS 6.8 and Prism Central 2024.1, every VPC had an active standby gateway pair. Translation: two gateways, but only one doing any work. Your throughput was capped at what a single node could handle. And if that host went down, you'd wait for the standby to take over, potentially interrupting connectivity for a period of time. Wasn't ideal, but we've come a long way since then. In May 2024, we launched No NAT Gateway Scale-Out with AOS 6.8 and Prism Central 2024.1. Then in December of 2024, with AOS 7.0 and Prism Central 2024.3, we brought that same functionality to NAT external networks. Now you can deploy up to 4 active gateways per external network per VPC, giving you multi-node throughput with traffic balanced across all gateways using ECMP. If a gateway or a host fails, the others keep running. The platform auto-migrates that gateway to a healthy node with no disruption. No more bottlenecks, no more single points of failure. And it's completely flexible too. Each VPC gets its own gateways, 2 by default, scalable to 4 based on what you need. More VPCs means better load distribution across your AHV nodes. As your environment grows, managing dozens of VPCs with their own external connections can get messy pretty fast. Transit VPCs solve this. Think of this as a hub and spoke. Instead of every VPC connecting to everything individually, you route through a central Transit VPC. It's a real clean, organized architecture. So what can you do with the Transit VPC? You can centralize shared services there. Things like DNS or file services, directory services, hosted in the Transit VPC. Everything connected to the Transit VPC gets access to that, rather than having to duplicate your infrastructure multiple times. You can simplify routing, have the Transit VPC handle BGP and static routes at the transit level, not in every VPC. The transit dynamically controls which overlay subnets get advertised to your physical networks, one configuration point instead of dozens. Transit VPCs have the same gateway scale-out we already talked about, so multiple user VPCs can share those scaled-out gateways. More efficiency, less complexity. Transit VPCs transform that sprawling web of connections into a more intelligent, scalable hub and spoke architecture that grows with you. Better throughput, better resiliency, less complexity. Just clean networking that scales with you. We've covered a lot of ground so far. Now let's look at how easy it is to configure gateway scale out along with a Transit VPC in Prism Central. We'll start with creating a Transit VPC. In Prism Central, we go to Virtual Private Clouds, then click on Create VPC. After naming the VPC, we select the box for Use as Transit VPC. Next, we'll associate an external subnet with this Transit VPC. This is where we configure our gateway scale-out. Once you've selected the subnet to attach to the VPC, cruise down towards the bottom and hit the arrow button to expand the external gateway configuration section. This is where we specify how many gateways we'd like to deploy. You see the default is 2 active gateways. For this demo, we're going to scale this out to 4. Once this is created, we're going to check out this new Transit VPC. When you select the associated external subnet section on the VPC summary page, you see the IP addresses of the scaled out gateways and the hosts those gateways are assigned to. We want to connect a VPC to the Transit VPC, so we'll start by creating an overlay external network, something we talked about earlier. Now we're going to attach our tenant VPC 01 to the transit using this overlay external network. Now all traffic from sources or destinations outside of tenant VPC 01 will go through this Transit VPC. Since we're using a no-NAT network, the last step we want to do is allow the Transit VPC to route our tenant VPC overlay subnet to the rest of the infrastructure. To do this, we update the Transit VPC by configuring the externally routable prefix, which is the IP subnet of our tenant 01 VPC overlay network. And that's how easy it is to scale Flow Virtual Networking VPCs. Thanks for watching and stay tuned for more great videos from Nutanix.